everyone, welcome back to my lecture. My full name is Prof.Dariga. I am from Kazakhstan. I work at Sydney State Medical University as a teacher of public health and math statistics. In today's lecture, I am going to tell about hypotheses. So, I hope that it will be helpful for you. Welcome to my video on hypothesis testing. Today I am going to explain information a little bit about type of hypothesis, Pearson's chi-square test, student's t-test, and ANOVA. Well, the purpose of hypothesis testing is to aid the clinician, researcher, or administrator in reaching a conclusion concerning a population by examining a sample from that population. Hypothesis has two types, research and statistical. Research hypothesis is a conjecture or supposition that motivates the research. While conducting a research, one of the most important considerations is the formulation of hypothesis. Hypothesis is a hunch or assumption that you want to test for possible acceptance or rejection. Hypothesis isn't necessary for any research, but hypothesis formulation is significantly important in research. A researcher might not be able to conclude before conducting the research about the phenomenon, situation, or condition that he is studying in his research. Hypothesis formulation makes it easier to go in particular direction and get the conclusion. Statistical hypotheses are stated in such a way that they may be evaluated by appropriate statistical techniques. For instance, scientists want to investigate how influence drug to patient's blood pressure. So before doing research, they suppose that patient's blood pressure will drop after taking the drug. It's research hypothesis. But statistical hypothesis has proved data. Only 60% patient's blood pressure will drop after taking drug. Statistical hypothesis has two types, null and alternative hypothesis. Usually null and alternative hypotheses are two mutually exclusive statements. They cannot both be true. What is a null hypothesis? A null hypothesis is a type of hypothesis used in statistics that proposes that no statistical significance exists in a set of given observations. The null hypothesis attempts to show that no variation exists between variables. The null hypothesis is generally assumed to be true until evidence indicates otherwise. In statistics, it is often denoted H0, H0. The null hypothesis, also known as the conjecture, assumes that any kind of difference or significance you see in a set of data is due to chance. The opposite of the null hypothesis is known as the alternative hypothesis. The researchers must then establish a value, or one or more sets of values, that would not support H0. If the data are found to be in agreement with these values, the null hypothesis will be rejected, and the alternative hypothesis can then be said to be probably true. For example, a drug company may be testing the results of a new treatment to reduce cholesterol. In this case, the null hypothesis would be that cholesterol levels are not reduced after taking the drug, while the alternative hypothesis would be that levels decrease. H0 would be assumed to be true, and researchers would then gather data to be analyzed in an attempt to reject it. The data might consist of cholesterol measurements in a sample of people before and after taking the drug, compared with a similar sample who didn't take it over the same period. The researchers might then agree on how much of a reduction and in what proportion of the sample who took the drug can be regarded as significant. This information can be used to set a critical value, such as a reduction of 10% in 80% of those who took the drug. If the data fall above these values, the null hypothesis is rejected and the alternative hypothesis accepted. Let's talk about steps in hypothesis testing procedures. The first step is evaluating data, the next is review assumptions, then stating hypothesis, selecting test statistics, determining distribution of test statistic, stating decision rule, calculate test statistics, and making statistical decision. After all steps, we reject or accept null hypothesis. The next information is about the p-value. The p-value is used to determine the statistical significance of the results. A p-value that is less than or equal to 0.05 is usually used to indicate whether there is strong evidence against the null hypothesis. The opposite is true. The p-value is the level of marginal significance within a statistical hypothesis test, representing the probability of the occurrence of a given event. The p-value is used as an alternative to rejection points to provide the smallest level of significance at which the null hypothesis would be rejected. A smaller p-value means that there is stronger evidence in favor of alternative hypothesis. There are a lot of tests to check our hypothesis. For example, Pearson's chi-square test, which is created by Pearson, William C. Gossett, who developed the t-statistic and the analysis of variance, or ANOVA, created by Ronald Fisher. A chi-square test is any statistical hypothesis test wherein the sampling distribution of the test statistic is a chi-square distribution when the null hypothesis is true. Without other qualification, chi-square test often is used as short for Pearson's chi-square test. Chi-square test can be used to attempt rejection of the null hypothesis that the data are independent. In this test, we are going to take observed data. So what is expected data? For example, in 2017, females were hospitalized to oncological clinic with cervix cancer. You decide to observe statistical data during 6 months, from January to June. In January, observed data was 22, in February 24, in March 38, in April 30, in May 46, in June 44. Total amount of observation is 204. So 204 patients got treatment in oncological clinic during 6 months. To calculate expected data, you should take total amount of observation and divide it by 6. 6 is total number of months, so expected data is 34. Well, meaning of null hypothesis in chi-square test is there is no significant difference between the observed and expected frequencies. After statistical calculation, we should reject or accept null hypothesis. Let's start to calculate. Firstly, we define degree of freedom using special table called chi-square table. The second step is defining critical value or chi-square value. Look at the degree of freedom. We circle 5 because we have 6 months. If you have 8 months, we will take 7. Look at the graphic illustration. We circle 0.01 because area in the table is equal to 0.01. So our critical value is 15.086. The next step is to calculate test statistic using the given formula. So t-test statistic is 15.29. Well, test statistic is higher than critical value. We reject our null hypothesis. Just imagine, if our t-test statistic was lower than critical value, we would accept our null hypothesis. But in our cases, we rejected null hypothesis. In conclusion, there is significant difference between the observed and expected frequencies. Student's t-test. A t-test is any statistical hypothesis test in which the test statistic follows a student's distribution under the null hypothesis. It can be used to determine if two sets of data are significantly different from each other. We use t-test to compare the means of two groups under the assumption that both samples are random, independent, and come from normally distributed population with unknown but equal variances. For example, 3-year-old babies take part in research. They are divided into groups A and B. They assess according to the weight. We can calculate all measures by hand or using Excel program. In our case, we use Excel program. Firstly, we should define means in two groups. The mean is obtained by adding all the values in the population or sample and dividing by the number of values that are added. Secondly, standard deviation. Thirdly, variance. The standard deviation is a measure of how spread out numbers are. Symbol is S. The variance is defined as the average of the squared difference from the mean. Our sample size is 16 in two groups. Symbol is n. To calculate t-value, we use a given formula. Firstly, we define difference between two groups, then variability of groups. So, means standard deviation are calculated and sample size is given. Well, we transfer these numbers to the formula. Our t-value is 2.3. After calculating student's t-value, you should run two students' t-test to test our null hypothesis. Well, meaning of null hypothesis in student's t-test is there is no significant difference between the samples. After statistical calculation, we should reject or accept our null hypothesis. Okay, first of all, we define critical value. Well, to define critical value, we use t-table. Look at the t-table. In our case, degree of freedom is 30. We calculate it by given formula. The first sample size plus the second sample size and minus 2. The first thing you have to know what kind of probability we use. Of course, in science we use 0.05 probability. So our critical value is 2.04 and t-value is 2.3. If our t-value higher than critical value, we reject our null hypothesis. If our t-value lower than critical value, we accept our null hypothesis. In our case, our t-value higher than critical value. We reject our null hypothesis. In conclusion, there is significant difference between the samples. Analysis of variance is a collection of statistical models used to analyze the difference among group means and their associated procedures, developed by statistician and evolutionary biologist Ronald Fisher. The analysis of variance, popularly known as the ANOVA, can be used in cases where there are more than two groups. When we have only two samples, we can use the t-test to compare the means of the samples, but it might become unreliable in case of more than two samples. If we only compare two means, then the t-test will give the same results as the ANOVA. For example, we can investigate how influence drinking habits to the health. First group drinks water, the next group drinks juice, and the last coffee. We should define variation within and between groups. Also, we can conclude that coffee may be more effective in the morning rather than in the evening. Okay, my lecture is over. I hope it was useful for you. Thanks a lot for paying attention. Goodbye.